Hello and welcome to this new video. In this video, we will study two very important concepts of group theory that are order of group and order of an element. Okay, we start with the definition, that is order of group, and this definition is the number of elements of a group and these number of elements can be finite or infinite, is called its order. We will use cardinality of G to denote the order of group G. Also in some books the order of group is denoted as this, but we will use in our videos the group order as cardinality of G. Now we will see some examples. The first example is set of integers with respect to addition is a group with respect to addition, sorry, is a group with infinite order, as we see that there are infinite many elements in the set of integers. And we have another group which we have previously studied, that is 1, minus 1, iota and minus iota. This is group under multiplication, and this is group with order 4. Okay, we move to the next definition, that is order of an element. And this definition is the order of an element G in a group G is the smallest positive integer n such that G raised power n is equal to identity element. And if the group is with respect to addition, in addition, actually we have already seen that this Gn means we have applied the binary operation of group n times between the element G. And if the group is under addition, then the notation of this integer, this would be ng. Ng means we have added G n times. It should be equal to 0 because with respect to addition, the identity is 0. Okay. If no such integer exists, then we say that the element G has infinite order, and the order of an element G is denoted by as this one. Okay. Now we have some remarks. To find the order of an element G, we just need only to compute the sequence, that is G, and the second element of the sequence is G square, third element is G cube, and so on, until we reach the identity for the first time. And then that integer, which will be the power of that element when we arrive to the identity at the first time, is called the order of that element. Okay. If the identity never appears in that sequence, then G has infinite order. Now we will see some examples. First example is, we consider a group which is denoted by U15, and that is consists of 1, 2, 4, 7, 8, 11, 13, and 14. This is a group under multiplication modulo 15. Okay. The order of this group is 8, because we have 8 elements in this group. And if we want to find the order of an element, say this element 7, what we have to do is we will find 7 to raise power 1, which is equal to, of course, 7. Then 7 to raise power 2, which is 49, and that 49 is actually congruent to 4 modulo 15, because this group is under binary operation multiplication modulo 15. Okay. Now if we take 7, 3, that will be 4 multiplied by 7, which is 28. And when we find this 28, that will be 13 modulo 15. Okay. And then again, if we multiply this 13 by 7, we will get 91, but 91 is congruent to 1 modulo 15. Hence, 7 to the power 4 is equal to 1, and 1 is the multiplicative identity. So in this sequence, first time identity appears when we take the power of 7 is equal to 4. So order of 7 is 4 in this particular group. Similarly, you can verify that the order of 11 is equal to 2, or order of 1 is equal to 1, order of 2 is equal to 4, and so on. You can find order of every single elements in this group. Okay. Next example is, consider Z10. This is also group under addition modulo 10. If we take the element, we can see that this Z10 is 0, 1, 2 up to so on 9. And if we take, we want to find the order of 2, we see in the addition, we have to add, if a group is a group under addition, then we have to add the elements repeatedly until we get the 0, which is additive identity. So 2 is equal to 2, of course, but if we take 2 plus 2, that will be 4, and if we take 2 plus 2 plus 2, 6, 2 plus 2 plus 2 is equal to 8, but in modulo 10, 2 plus 2 plus 2 plus 2, which is equal to 5 times 2 is equal to 10, which is 0 in this class. So order of 2 is 5 in this particular group. And similarly, we can find the order of remaining elements. Okay. We have another example. Set of integer is group under addition, and clearly the order of this particular group is infinite, and every element which is of course non-zero element has order infinite, because it is not possible to get 0 by adding any integer repeatedly with itself in usual addition. So that's all about this particular video. And if this video is interesting and helpful, then please like the video and subscribe the channel. Goodbye.